As we progress in this chapter, keep in mind that geometry is more than just about area and distances and fancy formulas. We certainly use it to help solve problems. So this particular example is about installing a circular swimming pool. So we'll read this example. It says, Joss would like to install a 24-foot diameter circular swimming pool in his backyard. His backyard is a rectangle 58 feet wide and 46 feet deep. He wants the side of the pool to be 6 feet from the edge of the west side of his yard and 10 feet from the edge of the back of his yard. Joss already has a rectangular patio that extends 30 feet from the edge of the east side of his yard and 14 feet from the front edge of the yard. Given these dimensions, will Joss be able to install the swimming pool without disturbing his patio? Now, contractors, designers, and planners all use some sort of coordinate graphing to help in the development stages of some layout that they're designing. So we will too. So I'm going to put in a graph here. And I'm going to use this graph as a layout for Joss's backyard. So the first thing I'm going to do is I'm going to go ahead and put in the axes here. Here is the vertical axes, the y-axes. And here is the horizontal axes, the x-axes. Right here is the origin, of course, where the two axes intersect. But I'm going to count off these tick marks here, these hash marks here by 2. So this will be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I'm only doing that because of the size that we're dealing with. 22, 24, 26, 28, 30. And this is in feet. 32, 34, 36, 38. Here's 40. 42, 44, 46, 48, 50. 52, 54, 56, 58, and 60. And I'm going to do the same for the vertical axes. If this is 2 here, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, and here's 40. It says now that his backyard is a rectangle, 58 feet wide and 46 feet deep. So I'm going to put in his backyard, and you can imagine that this is going to be like a top-down or an aerial view of his backyard. So here is 58 feet. The origin is here. I count all the way over 58 feet here. And then if we go deep 46 feet, here's 42, 44, here's 46 deep here. You can see here's 46. So maybe his backyard will look something like this. So here's his backyard, 58 by 46 feet. Also, he has a rectangular patio. It extends 30 feet from the edge of the east side. So maybe we'll mark this as the west. Here is the north. This will also be the back of his yard. Here's east. And here's south. This will also be the front of his backyard. The front edge of his backyard, right? So it extends 30 feet from the edge of the east side. So I'm going to come in 30 feet this way. If this is 58, here's 48, that's 10 feet. Here's 38, that's 20 feet. And here's 28, that's 30 feet. And then it also is 14 feet from the front edge. So then I'm going to bring this up 14 feet. Here's 10, 12, and 14. And here's his patio. So his patio is 30 feet by 14 feet. A couple other things. He's got a 24-foot diameter circular swimming pool. Keep in mind that a 24-foot diameter is a 12-foot radius. And he wants that pool to sit so that the side of the pool is 6 feet from the edge of the west side. So he wants it to come in 6 feet this way. 2, 4, 6. So he wants it to be 6 feet up here. He wants it 6 feet away from the edge of the west side and 10 feet from the edge of the back of his yard. So he wants it to come in 10 feet. Well, if this is 46, here's 36 here, so he wants it to come in 10 feet here. So this is 10 feet this way. I'll mark this as 10 feet in. I'll mark this as 6 feet in. So when he puts in his pool, the circular pool, it's going to butt up like that. Now his pool, since it's a 24-foot diameter, that means it's got to come in 12 feet this way and 12 feet this way. So we'll go 2, 4, 6, 8, 10, 12. 2, 4, 6, 8, 10, 12. So the center of his pool will sit right here. This is 12 feet. And this is 12 feet. So that's where the center will be. So you can see where the pool will come in at. The circular pool. Now the point that we're concerned with is right here. When we put the pool in, will it hit his patio? Because given these dimensions, we'll just be able to install the swimming pool without disturbing his patio. That's what we're concerned with. So visually, it doesn't look like this is 12 feet over to here, right? If it was 12 feet, it looks like the pool was going to hit his patio, but it doesn't quite look like it. But we're going to do it mathematically. This coordinate right here, this is at 28 and 14. Keep in mind, this is all in feet. This coordinate here, that's at 18. And 24, right? So now that we know where those coordinates are, we're just going to use the distance formula. If this is more than 12 feet or 12 feet or more, then we know that we have a problem with the patio here. The pool just might not fit in there. So we'll go ahead and we'll use the distance formula. C is equal to the square root of a squared plus b squared, where a is equal to the absolute value of the difference of the x's. So here are the x's. I've got 28 minus 18. 28 minus 18, that gives us the absolute value of 10. And the absolute value of 10 is 10. B is then the absolute value of the difference in the y coordinates. I've got 14 minus 24. That's equal to the absolute value of negative 10. And the absolute value of negative 10 is 10. So now we have C is equal to the square root of a squared. And what is a squared? That's 10, so that's 10 squared. Plus b squared, and what's b? That's also 10, so that's 10 squared. So this is equal to the square root. 10 squared is 100, plus 100. This is equal to the square root of 200. Using your calculator, you can determine the square root of 200. And the square root of 200 is approximately 14.14. And of course, we're dealing with feet, so we're going to write that as feet. So this distance here, that is 14.14 feet. So it seems like Joss does have enough room to put in his circular swimming pool, given these dimensions. So here we use the coordinate system to lay out a backyard.